Okay, we're going to be doing lead code 1020, number of enclaves. So you're given an M by N matrix, binary matrix called grid, where 0 represents a C cell and 1 represents a land cell. A move consists of walking from one land cell to another adjacent land cell. By adjacent means for directionally, or walking off the boundary of the grid. Return the number of land cells in the grid for which we cannot walk off the boundary of the grid in any number of moves. So I misread this the first time I tried doing this, and I thought that you just return the number of cells that are not at the boundary, right? So for example, if you look at this, I thought that you simply return these two and not these two, because these two, there are some positions where you can walk off the grid, right? But what they're saying is, because for example, these two, there's no way you can walk off these two and you end up off the grid. But they're saying as long as it's connected. So what this question should have been, return islands that are not connected to the border, right? But they are the number of cells within the islands that are not connected to the border, right? So here the answer would be 3, right? Because you have 3 land cells, right? Here the answer would be 0, because the only island that's there is connected to the border. So the first thing we're going to do is create a grid, create an algorithm to return the number of land cells, and then optimize it to eliminate the number of islands which are at the border, which are connected to the border, right? So let's first do number of land cells, right? So we're going to have our num rows, which is equal to length of grid, our num calls, which is equal to length of grid at index 0. Then we have our helper function dfs, which takes around a column. And then here we check if 0 is less than or equal to row. In other words, if the row is between 0 and num rows, right? And 0 is in between num calls. And I mean, the column is in between num calls and 0. And grid at this position, this cell, is equal to 1, right? Because we want to get the land cells. So when we're here, we set this cell to 0 to signify we've seen it, right? So we say grid row column is equal to 0. You can use any other, but this is the binary grid. You could use any other value as long as it's not 1, right? Then since we're looking for number of land cells, we return the addition. So we say return first this cell itself plus dfs rc, right? This is +1 plus dfs rc -1 plus +1 plus -1. So this is our helper function, right? And we have to consider the case that else, right? Else, if it was 0, you simply return 0, right? So when we come down here, we traverse our grid to find the number of land cells not connected to the end, i.e. number of islands, number of cells in islands not connected to the border. So we'll say num cells is equal to 0, and then we'll have for row in range num rows, and then for column in range num columns, right? And here we'll check. We check if we've found a land cell. So if grid at row, grid at column is equivalent to 1, then we get all its connected land cells, right? And determine if it's a valid island, i.e. an island not connected to the border, right? So how do we do this? DFS, we will have here num cells is equal to DFS row column, right? But this, as it is right now, right? Plus equals, actually, this will be plus equals DFS row column. So as it is right now, it's going to give us just the total number of cells, land cells, right? There's no filter. What did I use? I used O. There is no filter, right? You see, it gives us 4. For this example, it gives us 1, 2, 3, 4. So the way we filter this out, this is a separate island, right? So the way we filter it out, we say, we come here and we have a global variable called is, we'll say not connected. Not connected is equal to true, right? And then when we come here, we determine, right? we determine if this is a cell within an invalid island, i.e. an island which has a cell at the border. And how do we do this? We use a simple condition. If row is equal to 0, in other words, if the cell is somewhere on this row, or if the cell is somewhere on this column, right? Or row is equivalent to num rows at -1, right? Either this first row or this last row. Or column is equal to 0. In other words, if it's this column, or C is equal to num cols -1. Otherwise, if it's this column, right? So this row is equal to 0 is this row. Row is equal to num rows -1 is this row. Column is equal to 0 is this column. Column is equal to num rows is this column, right? So you see that this whole part here is covered, right? So if we find any cell that's at this location, then we know that this island is connected to the border. So we say self dot not connected is equal to false, right? So when we're coming here, we only want to add islands, right? We only want to add islands that are not connected. So what we do is we get we get the total here after we make the function call, and then we check if self dot not connected, because once it goes into this function call for this island, it will determine at one point whether it's connected or not. If this doesn't run, it will remain true, right? So if self.connected, then that means this code here was not run, right? Then we simply do num cells plus equals total, right? But remember, if we've set this global variable to false, at a certain point we need to reset it. And where do we reset it? We reset it here. We'll say self dot not connected is equal to true, right? So this is the solution. So what's going to happen is we're going to start traversing the grid. Then when we find a land cell, we look for the rest of its connected land cell items, right? We first reset connected to true, not connected to true, and we go through it. If it's connected to the island, it will say false, and we won't add its total, right? We won't add this local total to the total for the num cells. But then if it runs through this code and never runs this, then it will remain true. So once we execute this code, we increment our num cells by the total. So this is the solution. Oh my god, I keep on making this mistake here. I don't know why. It's supposed to be 2 of those. And voila. That is our solution. It takes O of m by n. It's an O of m by n solution. And yes. So that is it. And thank you. Bye.